Hello. It is a little late. And by a little, it's almost 4. I was on my phone. I was playing games, and then I remembered I really wanted to do this problem before I went to sleep because I feel like I'm super close to finishing. I think I could probably do Matrix Search 2 today before going back to sleep. I mean, milestone 9. And we would just have milestone 10 left to do, and those 3 problems are definitely going to be the longest ones that I'm probably going to have to take time on. So I just want to get done with milestone 9. Hopefully I can, but if not, it's fine. It just depends on whether I've done matrix search or not. So yeah, I don't know if you remember, if you watched the other video, you would have seen me talk about how I probably did this one, and the reason is because I had done it. The thing is, it was not a good solution at all. It was the most brute force that you can do. Double while loop with a condition or a call which had splicing inside of the argument and then splicing inside of the actual function and then splicing again here. It was a very slow. I mean, you could see that in the runtime. I don't remember why I was doing this. I think it was like a 2-pointer example problem that they gave us at the programming team meeting. I don't know. I was doing it. It's probably why. Yeah. This was very difficult. But it's fine. So longest palindromic string substring. The problem is simple. All we're doing is we're given a string S and we're supposed to return the longest palindromic substring inside of it. A palindromic substring would be a substring that reflects. So that means that the first character is the same as the last character, and you do that repeatedly until you get to the very middle. The middle, if it's even length, then the 2 middle numbers or the 2 middle characters have to be the same. Otherwise, the same one will be the same because it's only one at the middle. So, like in this case, we have A and A are the same, and then we have B right here. B is the same as B. So yeah. And then over here we have, I mean, no, it's not really, I guess it does kind of count. So this is like an even one where we have B and B, and because it's even, I have to count the 2 in the middle, and since they're the same, or check the 2 in the middle, since they're both the same, that is the palindromic substring. So it's pretty simple. We have a length of strings limited to 1000, and the string can only consist of English letters or digits. Lowercase, or is it? No, not lowercase. It could be any case. I don't know if it's case sensitive. I don't think it is though. I don't know. What does case sensitive mean? I think in the so basically what I'm trying to say is I think that this one uppercase does matter, lowercase does matter. But it's fine. I don't know if that's case sensitive or not. I think it is. But yeah, so this one actually has a different answer, or at least this one has a different formatting. It does include spaces, which is completely different. So my algorithm had to have a strip function inside of it. I think I could just change that really quickly right there. There we go. So for this one, I did need it because this one, the CTI's one, has spaces in it. Not that big of a deal. Just strip it afterwards. It should be just fine. Same thing. So yeah. Actually, that probably wouldn't work because if you have like a substring where there's like a billion spaces, but there's like 1 character in the middle of it, and then you have a substring that's 2 characters on the right of that. Anyways, that's not the problem though. The leak code had a different problem. I'm assuming that this is what they meant, and then they just threw this in there because it's probably some test example from the original palindrome problem. but it doesn't meet the criteria of this, so we're not going to worry about it. And then in the solution that I submitted 32 minutes ago, this one got 43%, a lot better than this one, which is almost 5,000 milliseconds long. Let's look at that. So in this solution, I like how compact it is. Very nice. Everything's separated. There's a separate function too. I like the organization. I'm using self for global variables that are going to be used across the functions, so then they can easily get updated without having to return multiple values. I'm not really a fan of returning multiple values. It just feels weird. I feel like modifying global variables is probably better. Or just anything else. I don't know. I'm not a big fan of just doing that. Yeah. I guess sometimes you have to. In this case, I don't think I have to. And I think this looks better anyways. I don't think it would look good to have like two more parameters on top of the ones I currently have already, or to have a return type at the very end. That's fine. So yeah, we have a start position, which is going to be set to 0 initially, and we're going to have a max length position, which is going to, or max length number that's going to be 0, because we haven't found any substrings yet. And then all we're going to do is we're going to iterate through each of the strings, and we're going to use them as indices from where we're starting off. So basically we're going to start at 0, right? And then we're going to check, okay, well, since at the start all we're doing is we're starting at the current index and then the next index, so we're going to start, or the current index, or the current index and the next index, depending on whether it's even or odd. In this case it's even, but I mean, we have to check both cases, so don't worry about it. First, let's check the odd case. The odd case, we have left and right being pointed to 0 or equal to 0, so then both of them are going to be at B. That means we satisfy all these conditions where left is equal to 0, right is less than the length of the string, and the character at the left and the character at the right is the same character. So in this case, all we're going to do is we're going to check if the maximum length is less than the distance between the two plus 1. And it is, because we have right is equal to 0, left is equal to 0, so 0 minus 0 plus 1 is going to be 1. 1 is greater than 0 over here, so we're going to update the maximum length and call this the new largest substring. So we're going to set the start equal to the left one, because the left is going to be where the start is, the right is going to be the end point, but we don't even need to keep track of that because we're keeping track of the maximum length. And that's more like, it's better because we could just have a variable to quickly check like that, rather than having to do right minus start or something like that, or end minus start. So yeah, then we just update the new max length each time the max length is smaller than the current distance that we found in a substring. Now, the reason we know that these are all substrings is because of this condition right here. It's making sure that all the substrings that we're looking at are palindromic. And since we're expanding outwards or going outwards because of these two, where the left is going to the left and the right is going to the right, because of that, we know that all checks in between them have already been done, so we don't have to repeatedly check that. We can use those and build off of them basically without having to recheck everything one more time. We just have to check the new left part and the new right part to make sure that they're equal to each other to continue expanding. And we only stop expanding once we reach one of the ends. So once left is negative, right is past the outside of the string, or one of the two characters is not the same as the other. So in this first case where we have B, what's going to happen is left is going to go to -1 and right's going to go to 1. And that's not good because -1 is not greater than or equal to 0. So this condition will fail and we'll break out of this function going back over here. And then we'll go to the next one, which is going to be BA. We're going to do the same thing. We're going to check, okay, is left greater than or equal to 0? Yes, it's equal to 0. Right is less than string? Yes, it's true. So it's at 1. And then we're going to check if the string of both of those characters is the same. Is B the same as A? That is not true. So we skip this, we break out of the function, and we go to the next iteration where we will start at A. We repeat the process over and over again. And the reason that this is good is because of this little thing that we're expanding outwards, because we're expanding outwards, and we know that we can do this because palindromes are basically just mirroring characters across the halfway point. We could take advantage of that to make sure that we don't have to recheck all of these variables all of these strings multiple times. So we only have to check each substring one time, so n number of times. Or we have to check each character starting point n number of times for all the substrings that are palindromic within it. And eventually we'll get to the longest one. If the longest one that we found in that starting point is not greater than or equal to, or not greater than the maximum length we currently have, we just basically ignore it and do nothing with that, because that's all we're looking for. We're only looking for the maximum length, or we're looking for the biggest substring. So if we find a position where there is no substring that's bigger, we just basically keep moving forward. And yeah. And at the end, all we do after iterating through all of these and looking for all the substrings inside of them is we just return the string with splicing, where we start at the starting position that we found, so the leftmost or the left index of the largest substring that we found, and then the starting position plus the maximum length, because the length is going to be basically like kind of like one indexed. So because of that, we don't have to worry about adding an extra one to make sure that the last character gets included. What this will do is just make sure that we have all of the characters we need. So the start until the length of the max length of the, not the max length. So the start plus the length or the distance of the maximum size substring that's palindromic. And that will return the answer. So yeah, it's pretty cool. I really like this problem, even though it low-key hurt my brain trying to do it, or like, what was this, a month ago? Yeah, I was trying to do this, it was just not working, and then I got it to work here, and then this is a better solution, which makes sense. I think there's probably a better solution because this is still O of n squared, because for every character in the string, we are going we're going left and right. So yeah, I mean, it'd be O of, this is like O of n divided by 2, because we're going left and right, and it has early break conditions in case of any of these three conditions fail to be met. And that's pretty often gonna happen, so that's gonna happen pretty often, so yeah, but it's still O of n squared because we remove the constants. So yeah, O of n, and because it's getting called O of n times, it's going to be O of n squared time. Because we're storing things as indices and lengths, we have constant space usage, and right here we just return a string with a splice. So yeah, that's the longest palindromic substring.